Okay, here are some practice problems for those of you that are needing a little bit of extra help on Unit 8 Quiz 2. These problems are most similar to 4 through 7. Okay, so solve for theta such that theta is in between 0 and 2 pi. Let's see, we should not have an equal to under that less than sign. So let's fix that real quick. Okay. So the first thing I can see here, I always want to try to factor as much as I can, especially when we're already equal to 0. So I can see that we have a cosine of 2 theta in common. So I'm going to factor out cosine of 2 theta. And that leaves me with 3 cosecant squared 2 theta minus 12. And now since these two factors are being multiplied together to equal 0, we can use the zero product property and set each of them equal to 0. So we want cosine of 2 theta equal to 0. And we also want 3 cosecant squared 2 theta minus 12 equal to 0. Okay, let's start on the left side. So cosine's already isolated. And then this 2 theta means we're going to go around the unit circle twice to find out the values where cosine equals 0. Well, we know cosine is equal to 0 at 0 radians and at pi radians. Nope, just kidding. That would be sine. Sorry. We know that cosine of theta or angle equals 0 at pi over 2, because this is 0, 1, and at 3 pi over 2, because this is 0, negative 1. And cosine is our x value there. So now we want to go around the circle twice. So the first time we go around, we get pi over 2 and 3 pi over 2. The second time we go around, remember we're just adding pi over 2 for every quarter turn. So if this is 2 pi, which is also the same as writing 4 pi over 2, then this would be 5 pi over 2, then 6 pi over 2, and then 7 pi over 2. So that leaves us with 4 values, but that's not what theta equals, that's what 2 theta equals, because cosine of pi over 2, if pi over 2 was in the space here, equals 0, and cosine of 5 pi over 2 equals 0. So we want to actually solve for theta. So in order to do that, we set 2 theta equal to each of those 4 values that we got before. So pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. And then that means for theta, we have to divide each of those by 2 to get theta. So we get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so those are just the values for the left-hand side. So I still need to finish solving on the right-hand side. So when I have 3 cosecant squared 2 theta minus 12 equals 0, I'm going to add the 12 to the other side. And after I add the 12, then we also divide by 3. So if I add 12, I get positive 12, and then divide by 3. 12 divided by 3 is 4. And then I still want cosecant by itself, so I need to take the square root, and oops, that was a little too far. Take the square root. Don't forget to do the plus or minus square root. So I get cosecant of 2 theta equals plus or minus 2. Now, we're not usually looking at cosecant on our graph, so we're going to take the reciprocal of cosecant, which means we can actually take the reciprocal of 2 as well. So the reciprocal of cosecant is sine, but the angle stays exactly the same, so that angle's not going to change. And then take the reciprocal of plus or minus 2, and you get plus or minus 1 over 2, 1/2. And then again on the unit circle, we're going to find where sine is equal to 1/2. So sine is our y value. So if I go over root 3 over 2 up 1/2, my x is longer than my y, which means this is 30 degrees, or in other words, pi over 6. And we want plus or minus 1/2. So all of those pi over 6 reference angles are going to give me solutions, and I'm going to go around the circle twice. So it'd be 5 pi over 6, 7 pi over 6, and 11 pi over 6. Then go around the second time. We get 12 plus 1 is 13 pi over 6, 12, 17 pi over 6, 12 plus 7, 19 pi over 6, and 11 plus 12, 23 pi over 6. All right. So with those 4 values, you're going to set 2 theta equal to all 4 of those, pi over 6, etc. And to solve for theta, you're going to divide everything by 2. So that would multiply the denominator by 2, because divided by 2 is the same as multiplying by 1/2. Please make sure you list out all the values, but you get the point. All right. Next problem. All right, so if sine of beta minus alpha equals -1/3, and cotangent of alpha equals -2, and both of those angles are between pi over 2 and 3 pi over 2, so those are, let's see, let's write something, let's annotate that for a second. Between pi over 2 and 3 pi over 2 would be quadrants 2 and 3. Determine in which quadrant the terminal side of beta is in. All right, so let's start with beta minus alpha. So our sine value is negative, and we can only be in quadrants 2 or 3. So quadrant 2, we know the sine value is positive, because sine is talking about the y value, and we're positive above the x-axis. So that means beta minus alpha must be down here. I'm actually gonna make that bigger so that you can see what's happening. This is beta minus alpha. And then your sine is -1/3, so -1/3, opposite over hypotenuse. So opposite side is 1 over the hypotenuse is 3. It's a -1/3, so we want to make sure that we have one of these values is negative. But we already know that if I go left by a value here, we're not sure what value yet until we do Pythagorean theorem, and then down, going down, this -1, this 1 is going to be negative. So that means the 3 must be positive in order to do a negative over a positive gives us a -1/3. All right, so then we do Pythagorean theorem to find the third side. So 3 squared is equal to -1 squared plus b squared. And we're trying to find out that other side. So we're going to do 9 minus 1 equals b squared. So we get b is equal to the square root of 8, which we know is 2√2. And that's a -2√2 because we went to the left of the origin, so -2√2. All right, now let's find the second piece, or our other triangle with cotangent, so of alpha. If cotangent of alpha equals -2, that means tangent of alpha equals -1/2. Now, tangent is only negative in quadrants 2 and quadrant 4. So we can't have quadrant 4. We can only be in quadrant 2 or 3. So that means that this triangle must be in quadrant 2. And tangent is, here, well, here's our angle, is opposite over adjacent. So the opposite side has to be a 1 and the adjacent side has to be a 2. And since we're in quadrant 2, our y value should be positive and our x value should be negative to give us a negative tangent value. Okay. So we did the Pythagorean theorem to find the third side. 1 squared plus -2 squared equals c squared. So that gives us 5 with c squared. So that means c is the square root of 5. All right, so I'm going to go ahead and try to make some of that smaller. If this allows me to. Maybe not. Nope. Whoa, okay. All right, that's not gonna let me make it smaller, so make sure you go back and make sure that you write down those triangles. But what we had, we need the side lengths of each. And then I need to be able to show my work for the rest. So we have 3, -1, and -2√2. We have 1, -2, and the square root of 5. Okay, now we want to determine which quadrant beta is in. Now, we're never given that beta is in between pi over 2 and 3 pi over 2. That's just for beta minus alpha and alpha. So I already saw that as a common mistake on some of the quizzes that you've taken. So you might want to go back and fix that. So we're not sure what quadrant it's in at all, but if we can figure out the sine of beta and figure out the cosine of beta, and whether they are positive or negative, then we'll be able to determine what quadrant we're in. But you have to figure out both of them. Otherwise, we won't know how to narrow down the specific quadrant. Okay, so in order to do that, we're going to do our sum of angles laws, but we're going to use beta minus alpha as one of our angles, and the other angle is alpha. Because what happens here is when I do beta minus alpha plus alpha, these two alphas are going to equal 0, and I'll get sine of beta. Okay, so, but I'm using the sum of angles on this portion over here by breaking it up into beta minus alpha and alpha. All right, so that gives me sine of beta minus alpha cosine of alpha plus sine of alpha cosine of beta minus alpha. And we're going to fill those values in. So using those triangles above is how we're going to figure out these numbers. So remember, this first triangle is beta minus alpha, and the second one is alpha. All right, sine of beta minus alpha is opposite over hypotenuse, so that's negative 1/3. Cosine of alpha is adjacent over hypotenuse, so that's negative 2/5. Sine of alpha is opposite over hypotenuse, so that's 1/5. And cosine of beta minus alpha is adjacent over hypotenuse, which is negative 2√2/3. Right, we add those together and we get 2, positive 2, because negative times negative is positive, minus 2√2/3√5. And when you do 2 minus 2√2, we know 2 times square root 2 is bigger than 2 itself. So 2 minus 2√2 is going to give us a negative numerator, which means we get a negative answer, which means our sine value is negative. So we've narrowed down that it has to be either quadrant 3 or 4. And then we do cosine of beta minus alpha plus alpha to find the cosine value, whether it's positive or negative. So we're going to end up doing that, and you should get, let's see, cosine of beta minus alpha, cosine of alpha minus sine of beta minus alpha, sine of alpha, which is negative 2√2/3 times negative 2/5 minus negative 1/3 times 1/5, which ends up simplifying. Negative times a negative is positive, so I get 4√2. And then we're subtracting a negative number, which is the same as adding 1. Okay, so we have a positive plus a positive, which is going to be a positive. All right, so whatever quadrant sine is negative and cosine is positive, which is quadrant 3 is our answer. And you want to justify your answer, and you would write out, because sine is negative and cosine is positive in quadrant 3, but this is really the work that I need to see to justify your answer. All right. So next problem, we have a sum and difference of angles here. So we're just gonna solve this out by using our sum and difference formulas. So starting with sine x minus pi over 3. So that gives us sine of x times cosine of pi over 3 minus cosine of x sine of pi over 3. All right, so that's just that left-hand side. Now let's do the right-hand side, but when we subtract, we want to make sure we put that in parentheses. Otherwise, we're going to get, we're going to forget to distribute the negative. So then that gives me sine of x cosine of pi over 3 plus cosine of x sine of pi over 3. So what do we have? Pi over 3. Cosine of pi over 3 is, well, our 60-degree angle. So cosine is going to be root 3 over 2. So sine of x cosine. Actually, let's go ahead and simplify this without plugging those in first, because if we distribute this negative right here, we get negative sine of x cosine of pi over 3 minus cosine of x sine of pi over 3. Which means these two are going to equal 0. And so if I brought that down, negative cosine of x sine of pi over 3 and negative cosine of x sine of pi over 3 is going to equal negative 2 cosine of x sine of pi over 3. And this is a solving problem, so we can move things to the other side in order to solve. But first, let's go ahead and plug in sine of pi over 3. So sine of pi over 3, that's 60 degrees. So our sine value at 60 degrees, I almost did that wrong earlier, is root 3 over 2. So we're going to do root 3 over 2 times 2 times negative 2 is cosine of x. So we get negative root 3 times cosine of x equals negative root 3 over 2. Divide both sides by negative root 3, and you get cosine of x equals positive 1/2. So you want to tell me the values for theta, which would actually be x, such that theta is in, or your x value is in between 0 and 2 pi. Remember, it cannot be equal to 2 pi. So there shouldn't be a equal to under that. So cosine of x equals 1/2, and cosine, our x value, is equal to 1/2 at, ironically, pi over 3. you go over 1/2 of root 3 over 2. But cosine is also positive in quadrant 4, so that would be down root 2, or down pi over 3, which would give us 5 pi over 3. And 6 pi over 3 is equal to 2 pi. So those are our two answers, are pi over 3 and 5 pi over 3. And we don't need to go around the circle multiple times because I don't have a multiplier times my angle that I'm given. It's just x. So whatever you get for those values one time around are your two answers. All right. And I think we have one more problem. Yep. Okay. Evaluate sine of 15 over cosine of 195. Completely simplify your answer. So let's see. 15 degrees. Sine of 15 we can get by doing sine of 45 minus 30. Probably the easiest one. And cosine of 195 we can get by doing 240 minus 45. So now we're going to use our sum and difference formulas. Actually, both of them are difference formulas because I decided to subtract on both of these. So that would give me sine of 45 cosine of 30 minus cosine of 45 sine of 30. Or you can do sine of 30 cosine of 45. Either way is fine. And then for cosine of 240, cosine of 45. And remember, cosine's opposite, so I want to add here. Sine of 240, cosine of 45. All right, sine of 45, and I'm just going to plug in each of the values. So there's 8 values that I'm going to be plugging in. So we get root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30 is 1/2. Denominator, cosine of 240, that's 60-degree reference angle. So cosine negative 1/2. Cosine of 45 is still root 2 over 2. Minus sine of 240, if the cosine is negative 1/2, and 240 is in quadrant 3, that's going to be negative root 3 over 2. And cosine of 45 is, again, root 2 over 2. All right, so then if I multiply those together and then combine them, let's see, root 2 over 2, I'm sorry, yeah, square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Square root of 2 times 1 is square root of 2, so that's square root of 6 minus square root of 2 over 4, common denominator. 2 times 2 is 4, and then you subtract. And then the denominator is going to be negative square root 2 minus a negative would be plus square root 6 over 4. Multiply by the reciprocal, and the 4's will reduce. So you get square root of 6 minus square root of 2 over negative square root of 2 plus square root of 6. and plus, oh, this should be a plus sign here. I messed that up. So let's go ahead and fix our sign. I was like, oh, that equals 1. No, it doesn't. So let's change this. We're not going to subtract a negative. We're going to add a negative, which would be subtracting a positive. Changes this over here as well. All right. And then we get square root of 6 minus square root of 2 over negative square root of 2 minus square root of 6. All right. I hope that helped you guys. Just email me if you have specific questions about other problems, and I will try to explain them to you, but it's best if you email me a picture of what you've already done.